Welcome back to the Integrate Intelligently podcast. I'm your host, Jeff Brickler. Today I am I'd like to welcome two guests, of course, founder and CEO of CAD Talk, Scott Brickler, and a new guest all the way from Germany. Makes it really easy these days with the internet, but Professor Jörg Fischer. Today we're going to talk about reimagining PLM, configure to order manufacturing, the future of digital integration. So Scott, Jörg, it's great to have you on the podcast today.
Yeah, thank you. I'm looking forward to this one.
Yeah, I'm also looking forward. I'm happy to be here.
First, Jörg, let me say thank you for attending this podcast with two English speakers. I know that I appreciate that. This world now is much smaller with the internet, so we talk. I was in Sweden last week, so it's nice to be able to have these conversations across borders. So thank you very much for that. So Professor Jörg, tell me a little bit about your career, your experience, kind of who you are. Introduce yourself to our listeners so they can find you and know more about what you do and who you are.
Great. I will do that. So I'm Jörg Fischer. I'm a professor for product lifecycle management and digitalization. And let's say I started to study mechanical engineering with a manufacturing background, so production technologies. And then I went to Technomatics. Technomatics, do not know if you know Technomatics, was an Israel company. UGS bought it. UGS, which then was bought from Siemens, the Teamcenter guys, and integrated in Teamcenter. And I was, I think, 1 year at Technomatics, and then we was bought from UGS. And then I started to do Teamcenter, and then I started to discuss about bombs. And the bombs start to be my most beloved topic. And I was at the GME account, Opel, and GM was one of the biggest customers of the UGS guys. And there you was very near with American architects and could discuss very deep about the current stuff and really cool technical things in Teamcenter. And then I started, one of my bosses asked me to create a kind of theory about bombs. So there was no documentation, there was no literature, no books. So I was on my own. And then I got professor in 2008 in Berlin for CAD, CAM and CNC. And I had then a team, was working with Siemens, and I had a team that we called it the BOM group or the BOM best practice group. And we discussed every Friday 3 hours about bombs. And after 1 year or 2 years discussing, I created a kind of theory how this is working, but nobody understood it. And there was very important thing. It was really cool. One day I wake up and I understood a very important thing. And it was that the partial models, meaning the structures within the company, within the IT systems, are the seed crystals of the processes. And this is very important. Nobody understood it. I wrote a mail to 20 people. They say, this is my new finding. Nobody understood it. They wrote crazy mails back. And I understood then that you can understand a company if you know which kind of, let's say, partial model structures they have in the system. Because every information is flowing to this structure, for example, a CAD structure or a BOM or an M-BOM, whatever. The information is flowing to the BOM and then the BOM supplied downstream. And if you understand how it is, how it works, you understand the company. And with this idea, at the beginning, I told it everyone, but the people didn't understand. So it was really crazy. And I thought, can I talk about? Should I talk about? And then I went to Karlsruhe, was then professor for production management and started to be a consultant at Steinbeis. And I was in the first project at Viessmann Kühlsysteme. And I worked with his methods and was so great. They really liked it. And after 2 questions about the information flow, the people there I interviewed didn't know what's happening and couldn't explain it. And I then created maps. I call them lifecycle maps, where you can understand how information is flowing through to a company. And this was the beginning, 2014. And also I worked then, UGS was bought from Siemens. I think it's common. Then I worked also with Siemens because I had this idea from, let's say, value selling. I thought Or I told them, guys, you cannot sell Team Center with features and functions. You have to explain the customer problem.
And the value.
The value, and you have to solve the customer problem. This was the idea. And since I created in my Steinbeis a methodology to walk along information flows and understood them and could discuss it, I learned a lot about this. And so I started to understand customers more and more. And in parallel, I'm a professor, a typical professor, but I'm a consultant, and I, let's say, do in between strategy consulting and everything, because everything, let's say, you can subsum to the structures. So that's for the first thing. I think we'll discuss the rest.
Right. You can understand a manufacturing company based upon how its relationship between the engineering BOM and manufacturing BOM. Am I understanding that correctly?
Absolutely.
Okay.
And there is an interesting thing, maybe I will add this. So as I started to look at the information flow, I went deeper and deeper in the ERP system, typically in Germany, SAP.
Sure.
And SAP and the ERP systems are full of structures. I didn't know it before. I thought we have these standard processes. Everybody is talking about processes, but the ERP systems are full of structures. Meaning you have, let's say, you can imagine a company out of structures. It's a network of structures where processes are going through, and you can understand the company. Not only I just started to do it. Everybody can do it. If you understand the structures and the information flow into and from the structures, then you can understand the company. This is what I've.
It's just because it kind of it drives through basically through the supply chain of how things are made, and if you understand the structures of the bills and kind of what the requirements of the bills of material are, as far as like how MRP works to break down the bills, to figure out the buy versus sell problem and how it goes through the supply chains. And we often say this in our marketing as well, is that in an ERP, if the bill of material drives everything else, it is literally the central structure that drives the entire software.
Absolutely.
Yeah. And, without it, it doesn't do much.
As this may be interesting, I tell you that's the MRP bomb, where the MRP run goes over, is, let's say, the general of the supply chain.
Yeah, the general of the supply chain.
How the supply chain is working. Just simple.
Yeah, I think this would be a great conversation. I think we're gonna agree on a lot. That's good. Yeah.
Yeah. So I came from a different. So it almost sounds like this is something I was in a different career when I first started. I was in teaching. It almost sounds like the BOM is like the language of the company a little bit, right? It communicates like what it does, how it works, all kind of parts of it. It's the foundation for everything. Scott said, we say that's in our marketing. Do you find that people, maybe you don't now because you have your people, I think, I'll back up a bit. Do you find that people think it's too intellectual, right? Like you have discussions about bills of material, and it's true, right? Like it's what's on the surface is a small thing, right? Like it's just a list of parts. On the surface, it's a small thing, but really, like it's really complex, as you're saying. Not just the bill of materials complex, but its effects throughout the organization are complex.
Yeah, but I think the people maybe do not understand it, but they understand the necessity to discuss it. And let's say what the engineers do every day is resulting somehow in a bill of material and material. And there is a way, let's say, a maturity development of the bill of material from, let's say, the CAD. So it's not the CAD anymore, from, let's say, the requirements, the systems engineering down, but everything goes. So let's say the sink is the bill of material, and this is, let's say, the heart of the supply chain. Okay, and from there it goes, let's say, back. If you think in a closed loop approach, it goes back, let's say, to the development structure, to the development map. What is happening, and this is what I think people are understanding, in the past, a lot of knowledge was in the head of the people. And it was every process was, let's say, created that a person come, understand it, and let's say translate it and tell another person what to do. But now we, let's say, get this knowledge out of the heads into a network of structures. Will be serious about digitalization, you have to put it out of the heads. And this is the reason why, let's say, I get more and more doors open to discuss it. Because in Germany, we have the problem that we do not have so much young people which, let's say, can handle this. Though we understand the tools have to do a lot. We have to bring the knowledge out in the systems. And this is the reason why I discuss a lot about. And this is working, I think 10 years ago, there was not the time, but in between, the people really are coming, they say, please help me. How can we do intercompany processes? How can we control the supply chain worldwide? How can we do the bombs? How can we come from the E-bomb to the M-bomb? It's completely changed.
Yeah, you're seeing... That's a good point about like a lot of you have I know here in the United States, we have like the baby boomer generation, which is a very large generation of people that are retiring. And then you have the younger generation that's quite smaller. And a lot of that expertise is they're afraid that's going to be lost, and then the idea of how do we get that expertise kind of into the systems so the software can drive more of these things in the future, or the systems themselves drive that. So I think it makes a lot of sense what you're talking about, like getting that out of people's minds and more into, because then that opens up the future too of like AI and other systems to kind of help with those types of processes because all of those systems are based on the data. And as long as the data is digitized, then the AI can actually use it and access it and do things with it, make decisions and things like that. So.
There's an interesting thing to the AI. So, maybe you have them also in North America. So the idea that AI will solve all, everybody talk about. And I say, this is nonsense, because if you have no good network of data, you cannot train the AI. Right. You cannot train it. We do not have the data that you can train an AI. And this is a problem. And first of all, let's fix it. Then AI will help us. I'm quite sure.
No,
You're absolutely right. Yeah. Sorry, Jeff, go ahead. Yeah.
We say the same thing. We just had an event before. You have to still have the fundamental processes and get to your point, Professor, get it out of your brain, get it into the system. And then from there, with that data, AI can do something, can be really powerful. AI is kind of on top, as you said. We're still down the foundation. We're in the bottom floor in the basement. We have to get it in there still.
Yeah, absolutely.
And sorry, Professor, go ahead.
This is where we have to work hard. So let's say you can imagine a network of information which then is used in the processing systems like ERP. Okay? So the ERP is a processing system. It generates processes, generate orders. It follows up on orders. It, let's say, put together all the financial stuff, but it needs a kind of fuel. And this fuel you have to bring into it. And this fuel is a network which is developing. And there is what we call, I call it now lifecycle management, or XLM, because it's not only product data.
Right.
It's not only product. There's so much other data which has a life cycle. And this may be interesting thing. So you are also ERP guys. The problem of ERP systems in the past is that we thought that master data will not change or will seldom change. But this is wrong. Master data has a lot of change. And product data has the most changes. Let's say the sequence of change in product data is very high. So we have now the problem that we understand all master data has a life cycle, and a lot of ERP systems took that into account. So they do not have the functions. And this is the reason why we discuss so much about PLM. But we know the PLM systems came from the PDM systems and cannot do all the lifecycle management. So this is the next problem. And so we have now a new kind of problem, which is very interesting to discuss about.
When you say the master data doesn't change in the ERP, can you give an example of that?
Yeah, so this is typical. Let's say the example is that it is written in the old books. So if you read an old book, so I'm professor, I have to read the books, then the idea, the definition of master data is that you think it will seldom change. For example, if you have a customer record, okay, it may change, but maybe once in a year. Okay. So, and this was an idea. You have, let's say, master data. And for example, if you have a material, it lives theoretically forever. You cannot delete it in the ERP. Maybe you tried it once and this is absurd. You cannot really do it. So, and I think the problem of most ERP systems is that they didn't took into account that the lifecycle management of, let's say, the master database they have is important.
Okay. So like it's not flexible with the fact that the data could be, that the data would change over time. It's more, there's no light. They're thinking like, well, once I give it this material, then it's pretty much that forever, as opposed to that being just a stage of the life cycle of that thing
so
over time.
You understand, you need time correct data. So, and you have to be able to look back and say, it was, let's say, there in this way. And so typical things, with what revision I have manufactured what. So this is a typical problem you have every time. And it's classically in the ERP systems, nobody, so this is my experience. I would be very interested in your experience, is that the ERP guys don't care about that, right?
They don't care about the history, you mean, of what happened?
Let's say about lifecycle management of the data. So they discuss about processes and all this stuff, but really what it means that data is changing. Didn't have discussions or intensive discussion with ERP guys about it. But correct me if I'm wrong.
Maybe. Oh no, I think a lot of times they do care from the standpoint of cost. So like if I were to say like I made this part over time, and then I have the history of the job of how we made it. So and then we say we changed the design and we improved the design of it. And then we have another job that made it a second time. We can compare, they have the history of how the job was made from a cost perspective to know. And then depending on how you're doing costing, and how you do things with inventory, you can do average or last in, last out. There's different kinds of costing methods, but in so much as the costing part of it, they care. But as far as like, but I think I remember reading one of your articles, they don't care. They're not as sophisticated with like the supply chain constraints. So like, I think you had an article about how the material flexibility, that you kind of locks you into a material. And say you can make it, you can make a part and you can make it out of different materials, but the ERP and a lot of these systems force you to choose one, which limits the supply chain variability, ability and things like that. And that definitely isn't that. I agree with you. That definitely is an issue. It's somewhat inflexible with how it can react. But you're right. It doesn't past doing some kind of revisioning or some kind of job tracking. It loses a lot of that.
Yeah, I think what let's say if I subdivide typically between master data and transaction data. Transaction data is, let's say, valid forever. You have one transaction, you will save it forever. It's no problem. But the master data, this is a typical problem, and they do not understand what lifecycle means. So this is my thinking about it.
So master data, I think about item master data.
Yep.
And then bill of material master data, right? The structure of the bill. I mean, if I'm just keep it simple, like you're talking about like units of measure, right? Descriptions, that's the master data about a part, right? But that, I think what you're saying, if I understand correctly, is some of that master data is inflexible. It cannot change. So especially things like unit of measure, right? Descriptions, of course, can change, and you can revision parts. In some ERPs, you can have a revisioning system to track changes in master data. I don't know that the downstream people care if that master data changed, right? That may not care about the master data changing unless it affects, like Scott said, how it's going to be manufactured downstream. But I know some ERPs do track revisions of master data.
This is very interesting. I think parts or material do not have a revision. We can discuss it in a minute. But downstream, there are guys which are carrying, and these are the service guys. So if you stand on a machine or machine tool and you are from the vendor and want to change a part, and then you see, oh, it's the wrong revision, then you have a real problem. And this is what is happening. Okay, and this is the reason you care. For example, production maybe does not care. because they produce what they get. And there is a
Right.
lot, let's say, behind where you have to think about lifecycle management, and the revision topic is very important because let's say, and there we are with the ETO and the CTO. If you have an ETO approach, the form fit function, which is behind of interchangeability, which is behind of revision, does not mean so much because you only use a part once in one order. Okay? So it's no problem. You know who is communicating with whom, and then you can say, I have the new revision, just create a new revision. Nobody cares. But as soon as you start with configure to order, you want, let's say, to reuse the same part in hundreds of variants. And then form fit function becomes an imperative, I think. So this is what's changing, and changing also lifecycle management.
Yeah. So if I understand correctly, engineering to order ETO companies have for many years, I think, Scott, you mentioned this to me, that for many years have been pushing towards complete CTO companies, right? To get out of, when I worked on projects and consulting, it was the same. People wanted to reuse parts because they would say, like, yes, we're an engineering to order company, but so much of our designs are reused. We don't need to make parts. We want to reuse a part again, and drive more to that configure to order. And to your point that the revisions of those and which ones you make, it's important, because a machine that you built 5 years ago could have a revision of a part that that you've revised, 5 times again, but it's on different machines out there. And then the service person is looking at the machine, trying to fix it, and he has to figure out, well, which revision of this part, is it?
Yeah, and this is nonsense. This is the reason why a part does not have a revision. In the end, you have to think about, as a company, what is your, let's say, expectation from form fit function. Okay, and what is interchangeability? And then you have to create a new material number. So material has no revision. A document, or let's say a digital document, whatever, has a revision. And this is one of my, I think our podcast is too short to discuss all this. So
Probably.
This discussion on LinkedIn, it's really crazy. And the discussions are so hard about this. Everybody's talking about it. And I think we have to solve it. And it's not so complicated if you understand it. So typically I would now show slides, but we cannot show slides in the podcast.
No, your points, I mean, just to kind of put a cap on that, like your point is taken about the engineer to order versus the configure to order. I mean, I think the idea of a one-off part, the idea of it falls apart as soon as you go to an aftermarket type of, or service type of situation. So as soon as you have, like, I came from the packaging, and we used to make packaging machines, custom packaging machines, but 50% of the revenue from that packaging machine company was aftermarket parts they sold for services. And if you change the design, like, too much downstream and too many revisions, they couldn't buy the old part anymore and it wouldn't work, right? So you always had to keep in mind, form, fit, or function, that your design didn't change the original design so much that it wouldn't work on the original machine, because they could always buy that part. So a common scenario would be that the engineer just creates a new number when they want to change the design for the next version. Yeah. So they don't change the original part. Absolutely. And then companies have, like, and I think that company had over a million part database when I left 20 years ago. And I think they have over 2 million parts today. So
I think it's not, let's say, if you have a good PLM implementation, it's not a problem if you have a lot of parts. So this is, in the end, let's say, the price you pay. Right.
Yeah. It's not, everybody thinks that lots of parts is bad until you have computer systems that can keep track of them just fine.
Yeah, absolutely.
But I still hear that, right? Maybe this is my inexperience, but I still hear customers come and say, I don't want to create new parts. And maybe that is a holdover from pre-digitization, right? Because you think, I have all these parts, I'll have too many parts. I've heard that. I don't want so many parts in my system.
Yes, there is, let's say, it's very, let's say, complex to explain, because I think there is a missing function in the ERP system. So I tell it every time to SAP, but up to now they didn't understand it. Because, let's say, the question is, what does a part mean? In the end, you have different, let's say, views on it. Because, for example, the guy who does assembly must be sure that the part he took out of the storage and assembles will work. Okay? So the, let's say, designer, for him, it's a little bit another thing. He do not know the problems which the guy has downstream. Though there you have different, let's say, kinds of similarity. And I talk then about, I call it the form-fit-function corridor. And the question is how you should have your form-fit-function corridor and what does it mean? And in the end, I think, and this is what I have a concept I call the virtual part or the part proxy. I think there should be in the future, in some cases, not every case, a kind of engineering parts which give birth to a kind of manufacturing parts. Okay, then you have a bracket which hold the parts together and which is the same from an engineering point of view, but not the same of a manufacturing point of view. If you can create this and also bring this in the controlling that you can switch between, let's say, the more differentiated numbers and the more, let's say, general numbers which are connected, then you can switch in every process what you need. Because in the end, it's just a question what kind of brackets or, let's say, boxes of things, of real things you want to put together. But we think also in a part, and I think, and this is maybe an interesting idea, that the idea of a part in an ERP system has to, let's say, be developed on a new level. And the interesting thing, it was not my idea, I found it. So there's an interesting guy, I like him very much, in Germany called Ulrich Schmidt. And Ulrich is a guru in SAP implementation. And he created with, maybe you know the IPPE, it's a let's say, a structure modeler in SAP. Nobody knows it. It's a treasure, and they didn't like it on themselves. And he created a kind of approach with a virtual part, what I explained. I've seen it. Was not my idea. I've just seen it and say, wow, this is what you have done. Great.
So like a part proxy. So it's really defined by the features of what it does, as opposed to there's the unique number. So it's like the case of your bracket. It's like, I need a bracket that can serve this function. How you make it is kind of a secondary process, but like, I need a bracket to hold. So you're almost defining it by the engineering function that it serves. Is that kind of what you're saying by the proxy part?
Maybe not the function. It's really a part. For example, so the engineer says this is a part. For example, let's say crankshaft or whatever. I do not know. Okay, so then you have maybe the problem that you produce this in North America or in Germany, the same company. But then you have the problem maybe with local content. Now you have here a manufacturer who did it a little bit in another way, who used maybe other manufacturing technologies, whatever. And it's nearly the same. So a standard form-fit function will be okay. But if you, let's say, want to do, let's say, a digital twin, you have to differentiate it. Okay, and then you need, let's say, different levels of similarity. And I think this is the future of parts, that we, let's say, have a kind of part proxy, and we can really define, let's say, parts which get burst out of the proxy. Okay. So it's really not easy to explain it without, let's say, a lot of pictures, but I see it, and the interesting thing, it's really interesting. As I understood it, I went out and I'm doing these information Gemba walks that I see what the guy's doing, and I found it. So if I tell this to customers, they say, we do it, or, oh yeah, I understand, we need it. And in the end, it's also interesting, you may know it. What is happening if you do not have it? So if you have a production order, the production order has a component list, which is the bill of material for the production order. And there they are changing it. And if they are not allowed to change it, then they do it on the shop floor and nobody realizes.
Nobody knows.
This is what is happening. Yeah. And so that means this is happening. And the question is, when do we in PLM systems or ERP system take care of it and say, we have to rethink the concept of a material?
I actually have a great example of this for you that we use all the time. It's a lot of time in when you cut parts with lasers or you do fabrication, there's different types of stainless steel. right?
Yeah.
And a lot of stainless steels have different finishes. So number 3 stainless has a polish on one side of the material. Number 4 stainless has polish on both sides.
Yeah.
Okay. Now, when you're cutting on a laser, often the more parts you have to cut, the better the utilization is of the laser.
Yeah.
So one of the things that we do a lot of times in fabrication shops is that they'll say, well, I have the part was designed to use number 3 because number 4 stainless is more expensive because of the polish.
Yeah.
But if I'm already cutting number 4, it's actually cheaper to cut more parts on number 4 at the same time.
Yeah.
So the flexibility to be able to change from number 3 to number 4, even though they will functionally be different, like they will only have polish on one side, but that polish means nothing to that part's requirements. So to be able to have the flexibility to decide in the supply chain is an example. Is that a kind of an example of what you're describing?
So I think this is an example. So we have more than this, but this is a very good example. And let's say as there are different cases. So I have a list of these cases and we discuss it. And the interesting thing, I have a nice slide for it from really C-level of a big company. And they liked it very much. This is exactly what we need. And this is maybe also an interesting thing, let's say the companies. So since we had the pandemic and let's say the fragile supply chains, and we had the discussion about resilient supply chains, many companies in Germany goes in what we call a factory network. Okay. And now you have Trump in North America. Now we create our shop floors in North America, I assume. And we have to think about, are we allowed to source in China to sell it in North America? And let's say the result is a factory or plant network. And this is the reason why the supply chain and let's say the part proxy gets more important, because the problem wasn't there. If you have, let's say, one development, one plant, no problem.
Right.
But if you have a distributed plant, then the things with local content, local customizing, all the question how you can source it, from where you get it, let's say the complex things. And this is what I'm recognizing. This is, let's say, a big discussions we have, and every customer has really these problems. They directly ask and say, help me, can you tell me how we do it or how we can do it?
So this is like you're going to manufacture a part. Let's say because you have multi-sites, as you're saying, you're going to manufacture a part, but that part can be manufactured in different sites. But each of those sites has different types of material that they get from different vendors, probably. And they may cut it on different machines or different ways slightly based upon their localizations. The fit, form, and functions are the same, but these are actually very different parts.
Yeah, and this is a question how you can follow up on it. So there are different methods how you can do it. So I know them in SAP. For example, you can have an equipment which is a kind of digital twin of a part. Let's say you can do these charge follow-up. I do not know the word in English. And then you can create an own material number for the local part. So this is what you can typically do. And this is what is happening. And I think this is not only, let's say, it's a topic which come up now. The reason it's just simple why it comes up. In former times, there was no connection between a PLM and a ERP. That means the supply chain guys did their own BOM.
Do their own thing, yeah.
So it was easy. They get the drawings, they get maybe a kind of BOM, and then they did whatever they want. But as soon as you start to do an interface between the systems, and you, let's say, supply the BOM from the PLM, the discussion starts. Because then the guys say, why do you change it? You cannot change it. They do not create processes that you can change it. And this is a problem. Then they cannot change parts downstream. I think this is one of the main problems. And this is one of, I call something, what I realized I call it ERP near PLM. I understood that there are a lot of lifecycle management processes which are in very ERP near. Just simple. If you have an order and you change the BOM in the order, you are in an instanced order already. So you have reservations on the orders and. And if you change then a material number, This is a life cycle process, but you do it on the shop floor, but you have to follow up on it.
Right.
And this is a typical ERP near PLM process. And I recognized also, and this is something I discussed, let's say, over years with the Siemens guys. And the problem is that I do not do, the concept of the plant bombs in SAP. So I do not know whether the other ERP systems has something similar.
They do.
Yeah, they have
plant bombs,
yeah. So, and these plant bomb model, the PLM systems do not have the plant bomb model. They say they have it, but they do not have it. If you really understand how the data model is, you understand they do not have it. Okay, and this is a typical problem. It's easy because they was systems which, let's say, supported development. They do not know an organization object as a plant. It's completely out of scope for them. And they just start, I discuss with a lot of, so I have, I think soon a discussion with a top architect of Teamcenter about plant bombs and what it really means. Because what they do today is that they, let's say, copy objects and create out of copying objects, let's say, copying a material and say, this is now a plant material. But this is not what a plant bomb means.
I see. Okay. Yeah. Like, well, what is the benefit of mirroring that functionality in both systems? I mean, if the ERP is able to, if the ERP is able to do the planned bombs, and there's a process for transforming the PLM representation of the bomb into the planned bombs, what's the purpose of having the planned bomb in the PLM?
This is a very good question, and I can give you the answer I really told Siemens. Yeah. This is a question of claiming. Okay, so in the end, plant bombs are a thing of ERP, and you change it in ERP, and it's done for years. Okay, but the question is, maybe let's, as an example, use Siemens. Siemens has this big story with the closed loop. Okay, they had an MES, they have the shop floor, and then think about the digital twin of the plant. Okay, and this is, in my opinion, a claiming question. And I really asked them, I think, do you want that you can create within Teamcenter a real plant bomb? If yes, then offer the possibility. If no, it's no problem, then put an EBOM to the ERP and do their MBOM. I'm absolutely agree, you can do that. But it's a question of claim. Okay? And
who owns it?
The interesting thing, if you want to have a strong system and you want to be in the core, in the heart of a company with your IT system, then you have to own the MBOM. And this is, for me, the reason.
Okay. So it's more just whether or not the PLM, I see what you're saying, is that in order for the PLM to be relevant, they want to own the MBOM, which because we've had this debate kind of internally a lot. It's like, well, when is PLM necessary, and when can you just get away with CAD, PDM, and the ERP? Why would you need what makes PLM a necessary thing at that point if you have these systems? Because a lot of the MBOM, most companies is controlled by the ERP. I mean, because that's the one that drives all the processes, as you mentioned earlier. So, that's always been one that I think we had a lot of debate about, is like, why do I need a PLM?
I had it yesterday with the Siemens guy.
Yeah.
And this is really interesting because there now we bring together the idea of the CTO Plus.
Mm-hmm.
Yeah. And also the idea of smart products.
Okay.
Let's start. So what a lot of companies have is something I call the supply chain side modular kit, meaning that the modular kit is industrialized in the ERP. And if you create a new product, you take what you have and, let's say, put something on top, just a little. Mm-hmm. So this is a typical CTO Plus, which is driven from the supply chain up to the PLM and then down. This is one point of view. But there's another point of view where you say, I develop brand new products with real new technology and systems engineering, model-based systems engineering. The combination of software is very strong. And the Siemens has a great story about this, that they say, take the product in the middle, develop the product, and with the product, you develop the IT and the OT. And then you deploy the IT and the OT. And you have to do the systems engineering to understand what is connected with what. And now we have these great tool builders and machine builders in Germany. The machines get more and more smart. They have more and more technology. And they have real problems because they do not have the systems engineering today. Okay? And this is the reason why the story is very strong. And I think that in the end, these both worlds have to come together. We need, let's say, a modular kit, which is connected to the development data in the sense of systems engineering, all this stuff. And this will be the future. So, maybe this is the reason why you say a PLM system can do it.
Okay.
Maybe it can do also an ERP system. In the end, the question is all the things come together, and the question is how do we find, let's say, architectures which solve it?
Yeah, I think you're right. I think there's a merging of these two different, like the merging of the PLM with the ERP over time, because that line between the design stage to the production, that's getting blurrier. You need a more seamless, because I think it was for many years you had these silos of engineers work over here and then the MRP production's over here, and then it's just kind of a throw over the wall to do it. But you kind of need a more kind of almost like everybody's singing from the same music, I guess is the way that is a term we use here in the States. It's like you have one sheet of music everyone's singing from. So yeah, that's a good point. That line to distinguish a PLM and an ERP is getting very blurry. I noticed that. Yeah.
Yeah, and I think this is what we are seeing on the market. And there are very interesting, let's say, developments you can see at the different vendors. And the question is how you can put it together. For example, SAP had this deal with Siemens. You know about it, right?
Mm-hmm.
Okay. And they started to sell SAP Teamcenter, so they called it. But they stopped it now. And I think it's very important because if, let's say, a company like SAP gives up PLM, what is left then in the end if everything is developed in the ERP? And I think this in the PLM. And I think this is what was not clear to them. Because, for example, they have maybe, the LOVC technology and all this cool stuff they have in the SAP as the configuration stuff. It's for me, this is PLM. This is product lifecycle management. And in the end, the question is, what will be the role of the ERP in the future? Will it only be, let's say, the order machine which bring the orders through? Will it maybe do the MRP run? Or will it also develop bombs and the whole net of information? I think this is, it's very important, for example, or very interesting. Do you know Propel PLM? Have you heard of them?
I know them.
I once had a call with these guys, really cool guys, and they create a PLM system on the Salesforce platform. You know that.
Mm-hmm. Mm-hmm.
And this is very interesting because you see there are PLM, or let's say a CRM near PLM processes. And they were the first guys who could explain it to me. I said, really great. Because I said, the question is from where does the development come? The new development. And if you have a long-living modular kit, the impulses of the new product come from the sales. Then you have to create out of sales the new ideas, and then is a sales near PLM very important. And if you think in, let's say, ServiceNow or service and CRM, then you put together the service and the sales, and then you told us that your company made, I think, 50% or 40% with service.
Right.
Okay?
Yeah.
Then development or a main source of development ideas comes out of a service. And it's so interesting. It's really amazing how the discussions, and you cannot say it, so everything is changing in the market.
Yeah.
So this is what, in my opinion, what I discuss and what I see.
Yeah, that's an interesting take on that, because like you're saying that the design decisions are being like, where is the design decision coming from? and then getting it closer to that point. So like from that, because like intuitively saying linking a CRM to a PLM doesn't make any sense on the surface until you understand the use case of like, oh, but this is driving from a server standpoint, or this is driving from a configurability standpoint. That makes a lot more sense. Yeah, it's like I never would have thought of that either. That was probably pretty interesting. Yeah.
Really, I just talked to the Propel guys. They're really cool, and they have really 2 slides which are so great. I like them. It changed my mind.
Oh yeah, yeah. We'll have to. That's another idea for a guest. That would be great.
Great. Yeah. This is a really good idea for your podcast.
Yeah, absolutely.
Well, Professor, we've been going an hour. It seems like you were saying that we could go forever. So, no, this was a great conversation. It really, even as long as I've been working with customers 10 years, there were areas where I just needed to listen because between the two of you in engineering and experience, I was a little out of my depth. But I learned a lot during this podcast. I really enjoyed the conversation. So. Professor, did you have anything else that you'd like to share? I mean, we're about an hour in, and I wanted to be respectful of your time. And where can people find you? What's the best place? Do you have you said you had a YouTube channel. How do they find you on LinkedIn, a website, and any of that you'd like to share?
Great, yeah, great. They can just Google or look at LinkedIn for Jörg W. Fischer. Because there are a lot of Jörg Fischers in Germany, really a lot. So I have this W in between. And follow me or connect with me. I really appreciate it. You can look on my YouTube channel. And I would like to have customers in North America. I want to have reasons to come to North America more. So as I was at Siemens, I was frequently in North America. But now I'm on the university. I have German customers or European customers, but no customer in North America, and would really like to come.
Okay. Well, it's funny. Actually, a good friend of mine is a product manager for Siemens, and their offices are here in Cincinnati. We're in Cincinnati, and so the Siemens offices are like right here because they years ago they bought ideas from the University of Cincinnati back in like the late 90s, and there's a lot of Siemens people here in Cincinnati. So yeah, well, that's great. It was really nice meeting you, Professor. So. We need to talk some more. I think it would be some great conversations. So
absolutely, I would be happy to do it. And I really enjoyed it. It was really great to talk with you guys.
No, that's great. We'll follow up and maybe have a take 2, right? A second episode.
Yeah. Great. I would be happy to be there. I think I only, let's say the questions you have given to me, I only will be discussed only half or quarter of them.
Yeah,
there's a lot of.
I figured there was a lot in this podcast. When you get experts, people who think about the problem this deeply, hard to just hit the surface. All right. Well, thank you very much, Professor. Scott, was good talking to you as well. So thanks all the listeners. Please look up Professor Jörg W. Fischer on LinkedIn and YouTube, and then of course subscribe to the Integrate Intelligently podcast. Until next time, great talking.
Okay.
Thanks everyone.
Thanks a lot, guys. Bye.